You must be wondering, we have done all of these examples where you could see, since you ended up with just one ordered pair as your solution set, that tells us those were the systems that intersect at just one point, that those we call as our consistent systems with independent equations, if you remember. Now what we want to do is talk about the elimination method for solving the special systems. Now again, remember, your special systems are where the two lines are either parallel or the two lines overlap. They're the exact same line. So let's go ahead and look at this equation here. You have 6x minus 2y equals 24, and negative 3x plus y equals negative 12. And we want to decide which one of the two special systems is this. You're still using the elimination method. So you want to go ahead and see which variable you want to eliminate, and then go ahead, and it looks like you will have to multiply one of the two equations with a number to eliminate it. Let's say we want to eliminate the x variable. To eliminate the x variable, you have 6 and negative 3. If I multiply my second equation by 2, that should help us out. So let's go ahead and eliminate x. So you have 6x minus 2y equals 24. Your second equation is negative 3x plus y equals negative 12. And we are multiplying our second equation by a positive 2. That should give us, again, your first equation stays the same. Your second equation will be negative 6x. This will also give you a negative 2y and a positive 24. When you add the two equations, what happens? Your x eliminates. Did I miss something here? Yes, I did. This was positive 2y. It should be a positive here, because this was 2 times positive y. So there we go. Your y eliminates, and this should have been a negative. Again, you can see it is so easy to leave those negative signs out, so be careful when you're working with these. So our x's got eliminated, our y got eliminated, and then you have a positive 24 and a negative 24, which also gets eliminated, and you end up with a true statement with 0 equals 0. Now, if you guys remember, we had talked about this. When you end up with a true statement, it means that the two equations are the exact same or equivalent equations, and that of course means they are two overlapping lines. So let's go ahead and look at that. Okay, so you have a true statement occurs when the equations are equivalent, and this indicates that every solution of one equation is also a solution of the other. So basically, there are an infinite number of solutions. And again, if you guys remember that for these sort of solutions, we use the set builder notation to write our solution set, and your solution set is going to be all ordered pairs. And again, you can use any one of the two equations here. Okay, so your solution set is going to be an infinite number of solutions. Okay, so the idea is when you use the elimination method and you go ahead and eliminate one of the variables and you end up with a true statement like 0 equals 0, that tells you that when you end up with a true statement, you have equivalent equations, and that indicates infinite number of solutions, and then you will have a solution set like this. Okay, want to look at one more example here. And this example, we are looking at our system, which is 3x minus 5y equals 1 and 6x minus 10y equals 4. Really doesn't matter which equation you choose to eliminate. Let's say we want to eliminate y this time. So if you want to eliminate y, you have 3x minus 5y equals 1, 6x minus 10y equals 4. So if you want to eliminate y, you can see these are both negatives. So one has to be positive, one has to be negative. And also, you have 10 and 5. 10 will go into 5 also. So I can multiply my first equation 2 times, and that will give me 10y. Now again, as I said, since both are negative, let's go ahead and make our 2 a negative number. That way, when you multiply, this number here will become a positive. So when we multiply our equations here, you will end up with negative 6x plus 10y equals negative 2. We don't really have to multiply the second equation with anything. So basically, if you multiply it by 1, it's the same idea. And if you go ahead and add the two equations, what happens this time? Your x's also get eliminated. Your y's get eliminated. So that gives you 0 on this side. On the other side, you have negative 2, 4, which will add up to give you 2. So in this case, you will see you ended up with 0 equals 2, which of course is a false statement. Okay? So when you end up with a false statement, that indicates that you have no solution, which means that the two lines are parallel lines. So as I said, your system has no solution. And if you remember, for these we use the empty set or the null set to show our solution set. Okay, so anytime you end up with a false statement, that means your solution set is an empty set. Anytime you end up with a true statement, that's when you have infinite number of solutions. Alright, and this will take care of our section 8.3. Awesome.